Hello everyone. So I'm redoing the example for related samples hypothesis test because I made an error in the calculations, especially at the very beginning for standard deviation. So I'm going to redo this video with the corrected standard deviations. Alright, so let's go ahead and start. So suppose you wish to test the effect of Prozac on the well-being of depressed individuals using a standardized well-being scale that sums Likert-type items to obtain a score that could range from 0 to 20. Higher scores indicated greater well-being. That is, Prozac is having a positive effect. Do the data indicate Prozac had a positive effect on or increases well-being scores? So here are our data. Right? So well-being was measured pre-Prozac, and here are the scores. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, n equal to 9. Okay? And then we gave the participants Prozac, and then we tested them post-Prozac, and here are their new scores, right? And because this is a related samples, we're not going to use these as individual or independent, right? These are related to each other. So we're going to have to measure, or we're going to have to calculate the difference scores. And I've gone ahead and did these in this column here. And since we're going to need to square everything for the standard deviation formula, I went ahead and squared everything so that we'd have everything ready to go. All right? So we're going to conduct the appropriate hypothesis test using alpha equal to 0.05 and show our conclusions in terms of this problem. We're going to use APA style conclusions just like I've shown in these videos. All right? So here we go. So the first step is going to be to calculate the sample statistics. So you're given a data set. Here's your data set here. And what you're going to have to do is calculate everything out, right? So our sample mean of the different scores, right? If we add up the difference scores, 2 plus 1, so that's 3, 4, 6, 8, 12, 15, 18, right? So 18 divided by n equal to 9 gives us a mean of the different scores equal to 2, all right? The next step, and this is where I made a mistake, I forgot to take the square root. So the sample standard deviation of the difference scores, right, we're going to need to add up all of the squared difference scores, right, and that gives us 48, and 18 squared is 324, all right, so this is d squared, the sum of d squared. This is this column right over here. And 324 comes from squaring 18, right? So we go ahead and do the calculations here. So we come up with 48 minus 36 divided by n minus 1, which is 8. That gives us 12 over 8. That gives us 1.5. We have to take the square root because this is standard deviation, right? So the standard deviation ends up being 1.2247. All right, now that we have our sample statistics, our sample mean, and our sample standard deviations, we can go ahead and start with step 1, which is state the hypotheses. So we've got the null hypothesis, which is always first, and that's the population mean of the different scores is less than or equal to 0. So Prozac does not increase well-being scores. Our alternative, population mean of the different scores is greater than 0. Prozac increases well-being scores. Step 2, set the criteria, locate the critical region. Alpha is equal to 0.05. We know this is a one-tailed test. How do we know? Our alternative, right? Our alternative says greater than, it's giving us direction, it's a one-tailed test. degrees of freedom, n minus 1. 9 minus 1 is equal to 8. Our t critical value is 1.860. So let me go ahead and pull up the t table real quick. All right, so here's our t distribution table. And we're looking for degrees of freedom, 8. So we're looking for the row where 8 is. And we're looking for 0.05, 1 tail, right? So there's 1.860. There's the proportion in 1 tail. There's 0.05. And there's our row for 8 degrees of freedom. So our t critical value is 1.860. This is the critical value that we need to beat. All right, so this brings us to step 3, calculate the test statistic. But before we calculate the test statistic, I want to go ahead and calculate estimated standard error, right? So that we don't have a fraction in the denominator of our t statistic, right? So our t-test is going to be the mean of the different scores divided by estimated standard error, where estimated standard error is equal to the square root of sample variance divided by n, which is equal to the sample standard deviation of this different scores divided by the square root of n. So I'm using the sample variance because it's an easier number to work with. So I'm going to take the square root of 1.5 divided by 9. This gives us the square root of 0.16667, which is equal to 0.4082. Now all I need to do is calculate the test statistic. So calculate our t. And it's really simple because it's just the mean of the different scores divided by the estimated standard error of the different scores. So the mean is 2 divided by 0.4082, and this gives us a t statistic of 4.8996. So, did we beat our t critical value? What's our decision? All right, so this brings us to step 4 to make a decision. So our calculated t is equal to 0.49, which is greater than our t critical value of 1.860. So yes, we reject the null hypothesis. Now, since we've rejected the null hypothesis, we need to measure the effect size, right? How big of a difference are we looking at, right? So I went ahead and did an r squared, and so I've taken the calculated t, 4.8996, squared that in the numerator, and then square it in the denominator plus the degrees of freedom, which is 8. So that's 24.0061 divided by 24.0061 plus 8 gives us 24.0061 divided by 32.0061, which gives us an r squared of 0.75, which is a very large effect. Now, I want to go ahead and calculate a 95% confidence interval. And we do that by taking the mean of the different score plus or minus the margin of error. So that's 2 plus or minus 1.860 times 0.4082. That's equal to 2 plus or minus 0.759. Our 95% confidence interval is 1.24 to 2.76. So our conclusion, our APA style conclusion, is that we reject the null. There is sufficient evidence to conclude that Prozac significantly increases well-being scores, comma, t degrees of freedom 8 equal to 4.9, comma, p is less than 0.05, comma, r squared is equal to 0.75, comma, which is a very large effect, comma, 95% confidence interval, bracket, 1.24, comma, 2.76, close bracket, period. And now, to sum this up in plain English, Prozac has a positive effect on the well-being of depressed individuals. And there we go. We've redone the related samples hypothesis test.